Hello students, this is Sudeep Yadav from Spectrum Chemistry, and students, if you are first time visiting to my channel, so please like and subscribe my channel and press the bell icon to get a best explanation of NCERT book class 10th subject science. And students, in science we will discuss chemistry only. So today in this video we are going to discuss the fourth part of the chapter metals and non-metals. And in this video we are going to discuss about the chemical properties of metals. So let's start, students. What are the chemical properties of the metals? So the first point which we have to discuss in this video, that is hydrogen gas is not evolved when metal is treated with nitric acid. So why hydrogen is not evolving when the metals are reacting with nitric acid? As we know that dilute acids, when reacting with the metals, they are having tendency to evolve the hydrogen gas during the chemical reaction. But here in case of nitric acid, why hydrogen gas is not evolving? So let's see, students, what is the reason behind it. Nitric acid is a strong oxidizing agent. This is the first and very important point to explain the answer for this question. Okay, so nitric acid is a strong oxidizing agent and it oxidizes hydrogen gas. Okay, means this will be oxidized, means hydrogen gas will be oxidized and it will be converted into the water, and nitric acid also be itself get reduced to some oxide of nitrogen like nitrous oxide, that is the N2O, nitric oxide, that is NO, and nitrogen dioxide, that is the NO2. Okay, so now another fact, copper, gold, silver are known as the noble metals because they are highly inreactive metals. So these do not react with water or dilute acids. So we will not discuss these metals, that is copper, gold, silver. Okay, now next point, nitric acid reacts with most metals, but the details depend on the concentration of the acid and the nature of the metal. Okay, means the products, whatever the products will form during the chemical reaction, they will be dependent on the concentration of the nitric acid. Okay, so dilute nitric acid behaves as a typical acid in its reaction with most metals like magnesium, manganese, and the zinc liberate the hydrogen. In the above given point, we have discussed that nitric acid is reacting with the metal, but there is a no hydrogen gas will evolve. But here some metals like magnesium, manganese, and zinc, here the three metals given, which on reacting with the nitric acid they will give hydrogen gas. So let's see, students, their reactions. Now first, magnesium, when react with nitric acid, it will convert into magnesium nitrate and hydrogen gas is evolving here. This is a very important point. As well as manganese, when react with nitric acid, here is a magnesium nitrate and hydrogen gas is evolving. Now next reaction, if you will be see with the copper. So in the above statement, given above statement, we have seen that there are three kinds of the product is possible when nitric acid is reacting with the metal, that is nitrous oxide, nitric oxide, and then nitrogen dioxide. So what will be the condition at which nitrogen dioxide will produce, nitrous oxide will produce, and nitric oxide will produce as a byproduct? So it is totally dependent on the concentration of the nitric acid, means these are the dependent on the concentration of nitric acid. See here, two reactions are given of the copper metal with the nitric acid. Number first, copper when react with the nitric acid, there is a copper nitrate and nitrogen dioxide is forming and water is evolving. Similarly, if you talk about this second reaction, that is copper when reacted with the nitric acid, copper nitrate, same product, but here the product has been changed, that is the nitric oxide, and water is forming. So here the concentration, due to the concentration difference, your byproduct will be also change. Is it clear? I think. Okay, now here you can see the reactivity series, number of times we have discussed already. Okay, so we are leaving it here. Now second point, reaction of metals with solution of other metal salts. Sorry students, reaction of metals with the solution of other metals salt is displacement reaction. In this reaction, more reactive metal displaces the less reactive metal from its salt solution. That is metal A. If you see this reaction, that is the common reaction, metal A will react with the salt of the metal B in the aqueous solution. Salt and the byproduct will be salt of the metal A and the metal B. So here's the common reaction. You can say a general reaction. For example, here is an example given, that is the Fe when reacting with Cu2 positive. You can suppose to it as a copper sulfate. Okay, because in the copper sulfate solution, the copper will exist in the form of copper 2 positive. So you can assume it as a copper sulfate solution. So Fe when react with copper sulfate solution or this Cu2 positive, so Fe is a more reactive metal than the copper sulfate. In the copper sulfate, in the copper, that is okay. So here Fe will displace the copper from its salt solution, that is the copper sulfate. So it will convert into Fe2 positive and copper will deposit. So this is the explanation for this reaction. Now similarly, aluminium and zinc displace copper from the solution of the copper sulfate. You can see here aluminium when react with the copper sulfate, aluminum sulfate and copper will form. Similarly, in the second reaction, zinc when react with the copper sulfate, zinc sulfate and copper will form. In all the above examples, iron metal, iron, aluminium and zinc, iron, aluminium and zinc, copper from this, these all are displacing these all are displacing the copper from its salt solution. Okay, so means why? Because these all metals are more reactive than the more reactive than the copper. So that is the reason behind it, they can displace the copper metal from its salt solution. Now next, similarly, when in all the above examples we have discussed already, this is why they displace copper from its salt solution. When the copper is dipped in the solution of the silver nitrate, it displaces the silver and forms copper nitrate. Why? Because copper is more reactive according to reactivity series, so copper can displace the silver from its salt solution, that is the silver nitrate, and copper nitrate will form and silver will deposit. In the reaction, copper is more reactive than the silver and hence displace the silver from silver nitrate solution. Silver metal does not react with the copper sulfate solution because due to its reactivity, because silver is less reactive than the copper and not able to displace copper from its salt solution. So here you can see this statement in the form of equation. So is a no reaction will take place if silver is placed inside the copper sulfate solution. Okay. Similarly, when the gold is dipped in the solution of the copper nitrate, no reaction takes place because copper is more reactive than the gold. Now next point, reaction of metals and non-metals. So as we know that metals having the tendency to lose their electrons to complete its octet and get the stability. Similarly, non-metals also having the tendency to gain the electrons and complete its octet to get the stability. Okay, many metals form ionic bonds when they react with non-metals. Compounds so formed are known as ionic compounds. So what are the ions? Before it, we have to know about that. What are the ions? So positive or negative charged atoms or the species are known as ions. Ions are formed because of lose or gain of electron. Atoms forms ions obtained by the electronic configuration of the nearest noble gas to get the stability, or you can say to fulfill its octet or to complete its octet. Now here two types of the ions. Number first, positive ion, that is also known as cations, and second one is a negative ion, that is also known as anions. So first we are going to discuss here positive ion. A positive ion is formed because of loss of electrons by an atom. Following are the some examples of the positive ions. When the sodium, as you know that the electronic configuration of the sodium, that is 281, okay, that is 11 atomic number. Sodium forms the sodium ion because of the loss of the one electron. Because of the loss of the one electron, one positive charge comes over the sodium. How? Because it has to be completed octet. So 2, 8, 1, from this electronic configuration, when sodium will lose one electron, that is the outermost cell's electron, okay, so at that time it will carry 2, 8, means in the last cell it having only the 8 electrons, means that is the octet rule. So it has been completed its octet, so it has been converted into a stable state, means this is converted into a cation, okay. After the one electron, when it has been lose its one electron, it will be converted into a stable state, that is Na positive. Magnesium forms positive ion because of the loss of the two electrons. So means two positive charges come over the magnesium because of the loss of the two electrons. You can see here in both the equations. Now negative ion. What will be the condition at which the negative ion will carry by the any species or any atoms? So it will be the condition in which when any atom or the any element will gain the electron during the chemical reaction and to complete its octet. So this is the reason behind it, to formation of the negative ion. A negative ion is formed because of the gain of an electron. Some examples are given below, that is the chlorine. When gain an electron, so it will convert into Cl negative, okay. So this is the chlorine anion. Now after the ion formation, what will be the next step? This is the ionic bond. Ionic bonds are formed because of transfer of electrons from metal to the non-metal, means this bond will form in between the metal and the non-metal. In this course, metal get positive charge because transfer of electron, and non-metal gets negative charge because acceptance of the electron. Like sodium has lose its electron and chlorine has gained the electron, okay. Similarly, in other words, bond formed between the positive and negative ion is called the ionic bond. Since a compound is electrically neutral, so to form an ionic compound, negative and positive both ions must be combined, okay. So this is the ionic bond. Now formation of the sodium chloride. So here you can see the first cell, in the first cell of the sodium having the 2 electrons, in the second cell of the sodium having the 8 electrons, and in the last cell of the sodium having the 1 electron. So to get this stability, to complete its octet, sodium can lose its 1 electron, okay. So in this process it will lose its electron, and you can see in the chlorine, in case of the chlorine, its first cell having the 2 electrons, in the second cell 8 electrons, and in the last cell it having 7 electrons. So it having a need of the one electron to complete its octet. So sodium will provide its electron to chlorine to complete chlorine's octet. During this process, the charge, the electrons is losing by the one species and the another species is gaining the electrons. So one species will carry the positive charge and second species will carry the negative charge, and this will be the neutral species. So that is known as the sodium chloride. So here in this equation, through this equation, you can easily understood that how the sodium chloride will form. Now, sodium has one valence electron and chlorine has 7 valence electrons. Sodium acquires losing 1 electrons to obtain the stable configuration, and chlorine requires gaining 1 electron in order to obtain the stable electronic configuration. Thus, in order to obtain stable configuration, sodium transfer 1 electron to chlorine. After lose of the 1 electron, sodium gets 1 positive charge and formed because of the transfer of the electron. Thus, the ionic bond is formed between the sodium and the chlorine. Since sodium chloride is formed because of ionic bond, thus it is called ionic compound. In similar way, potassium chloride is formed. So this was the explanation for the ionic bond and the ionic compound. Now, in the last, properties of the ionic compound. What will be the properties of the ionic compound after the formation of the ionic compound? What are the important properties of the ionic compound? So let's see, students, one by one. Ionic compounds are the solid. Number first, that ionic bond has a greater force of attraction because of which ions attract each other strongly. This makes ionic compound solid. Okay. Now second point, ionic compound are brittle in nature, means they can be break in a slices. Okay. So this is the brittle in nature. Ionic compound have high melting and boiling points because force of attraction between ions of ionic compound is very strong. Okay. Now third point, ionic compounds generally dissolve in water, and ionic compounds are generally insoluble in organic solvents. Organic solvents are kerosene, petrol, etc. And ionic compounds do not conduct electricity in the solid state. So we having the need to dissolve it inside the water, then they can conduct the electricity. Otherwise, they will not conduct the electricity if they are the solid form. In the solid form, the solution of the ionic compound in water conduct the electricity. This happens because ions present in the solution of the ionic compound facilitate the passage of the electricity by moving towards positive electrodes. Now last point, ionic compounds conduct electricity in the molten state. So I hope, students, you must have enjoyed this video. So thank you.